So now we're going to cover stacks. The chapter on stacks in the book is incredibly inadequate, and it's no longer in the array list section. It's been pushed down to chapter 18. Ignore that one. That one's implemented in an extremely odd way. Instead, use the PowerPoint. We have a PowerPoint over stacks and queues, and that's actually what we will be looking at, is stacks. Now, an array list is something where you can insert into the middle of it, or you can insert into the end of it, or at the beginning of it, and you can delete from the middle of it, or whatever. A stack is more specialized. When you add items to it, you're just putting them on the stack, like you have a stack of dishes. And when you take data out of it, you're removing them from the stack, just like a stack of plates. So you're really not supposed to be inserting, into the middle or the bottom of your stack of plates. Instead, you always just put stuff on the top, and then when you're ready, you take things from the top. So this is showing a stack where a 1 was added to it, and then a 2 was added to it, and so the 1 became the bottom, and then a 3 was added to it. And so now the top of the stack is a 3, where it was a 2. If we want to add data to the stack, we use a push operation. If we want to pop something from the stack, we use a pop operation. And then when we want to peek, we use the peek operation. That tells us what's on the top plate, so to speak, without actually removing it. So the syntax for creating a stack is far simpler than what they show in the book. So let's define our scanner just for fun in case we're going to ask for user input. Add the import for it. Now let's make a stack. Create a stack for strings. So stack, and we have to say what type it is. I'm going to call this stack names. That declares it. It does not actually create it, so now we're going to create it. Names is equal to new stack, like that. So it looks a lot like the syntax for creating an array list. We have to add an import for java.util.stack. So far we have 2 imports added to our code. Now let's add 3 things to our stack. So stack.push we're going to push Spider-Man onto the stack, except it's not stack.push. The name of our stack is names. And then names.push, we're going to add somebody else to it. Iron Man. Let's do Thor. Thor's cooler. And then let's tack one last name onto it. Hulk. There we go. Now we want to write a loop that will look at that will pop these values off the stack. You can actually use a for each loop to look at the contents of the stack without destroying the stack, kind of like if you were able to X-ray vision your stack of plates. So let's go ahead and write a loop that will peek at the stack. It's going to be a for each loop, just like a loop for iterating through an array or an array list. For each string in, or for hero, we've got a list of heroes here, in the names stack, we're just going to print that out. So we've added Spider-Man, Thor, and Hulk. When we run this, they're not going to print out in that order. the first thing on the stack. Okay, I lied. It is printing it out in the same order in which we pushed items onto it. However, let's peek at the top item of the stack now. So system.out.println, we're going to peek at our stack. Now that actually does not change the contents of the stack. It is a non-destructive examination of it. And so Hulk is actually the top of the stack. It's the first item on the stack. Just like if you have a stack of plates, it's the top item. Here we go. This 3 here is the top item on the stack. It was the last one added with a push. Now let's write a loop that will pop all the items off the stack. While names dot is empty is equal to false. We're going to get that name, string hero is equal to names dot pop, and we're going to print that hero off. System.out.println pop space followed by the name. Excuse me, I called it hero. And there we go. So we pushed Spider-Man, Thor, and Hulk on it. When we peeked, we saw that Hulk was the top item, and then when we popped them, they came off in the reverse order. Hulk was the first item removed. Thor was the second item removed. Spider-Man was the third item removed. Alright, I'm going to cordon off this code in a method so that it doesn't keep running. Public static void name stack whatever. There we go. Now let's create a stack of integers. Stack integer. We're going to call it I stack. It's equal to new stack. There we go. Now let's write a little loop that will let the user enter values into the stack until they type in -1. Enter a series of integers followed by a -1. And we're just going to use our favorite while true loop. Let's get an integer from input sc.nextInt. If it's a -1, we're going to break. Otherwise, we want to push it onto the stack. The syntax for pushing onto a stack is the name of the stack, followed by the push method name, followed by the data that you're adding onto it. Now, although this is a int rather than the wrapper data type integer, that's okay because ints convert cleanly to integers. They get boxed into integers just fine. So even though we declared it as type integer, it's totally okay just to push ints on it. And just like an array list, our stack has to be primitive, has to be non-primitive data types. It has to be reference types. It can't be it can't be ints and floats and doubles. It actually has to be the uppercase versions of those. Now let's print that we added something to that. System.out.println pushed %d. How many items on the stack are there? Stack size equals %d/n. And so we just pushed I, or we could do iStack.peek, either one. And we want the size of the stack, so iStack dot, whoops, not search, size. And since we use placeholders, I can't use print line, I have to use printf. Here we go. Enter a series of integers followed by -1. 10, 20, 30, 9, 8, 7. So my stack is 6 now. And the -1 to bail. Well, we didn't write anything that would display the contents of the stack. So let's write some code that will peek at the stack. For each integer I that's in the I stack, actually these aren't peeks, are they? This is just a for each loop which lets us get sneak previews of all the data on the stack. But that's okay. System.out.println stack contains plus an I.
Is there a way to, like if you want, depending on how many the person puts in, if you say you want to peek at the third one that they put in from the keyboard?
That kind of violates the spirit of a stack, but maybe we can. Let's go ahead and just print them all out first.
Okay.
So the question was, can we, if we wanted to see, for example, the third element of the stack, can we pull that out? And my response is that kind of violates the spirit of the stack, because really we should only be interacting with the top element. But it's convenient for our debugging purposes to be able to step through it. Okay, so a series of numbers, 10, 20, 30, 9, 8, 7. We've added all that data. The stack size is 6. Now we do -1, and there's the contents of our stack, kind of from the bottom up, in the same order in which they were pushed, 10, 20, 30, 9, 8, 7. Let's see if there's a peek. Int i's, I mean, if you can specify a value. I stack dot. Nope. You can't specify that with peek. Is there another one? You can use get, just like you can. Okay, so if I wanted to get the third element, I could do that. But like I said, that's really not the way we should be doing it. Peeked element 2, which is equal to. -20, 30, 9, 8, 7, -1. And so the third element, counting as 0, 0, 1, 2, was indeed a 30. But if we wanted to do stuff like that looking at the middle of it, then we probably would have chosen an array list or something else rather than a stack. So let's don't do this. Not really in the spirit of stacks. And honestly speaking, this really isn't either. So stacks are designed to only access the topmost element. So let's find out what happens if we push an element in and then we pop an element. Each time we add to the stack, we want to print our stack. So I'm going to take this code, our for loop, and put it into our while loop. And the reason I'm doing this is I want to see what the stack contains every single time. And we're going to give them another option. Or pop a value by entering a 0. So what this will let us do is if we enter positive numbers, they're added to the stack. Each time we type in 0, it pops an element from the stack. So after we do our next stint, if it's equal to -1, we break, else if, but we don't need the else because if we broke, we're out of the loop entirely. If I is equal to 0, we want to pop an element from the stack. Int I is equal to iStack.pop. Now really, if we pop and there's no data on the stack, it's going to generate an exception. So we should write more fail-safe code that checks the size of the stack first. But we're just going, I'm not making this error-proof at this point. System.out.println just popped plus that variable. I am going to change these to else ifs just because they look nice. And if it wasn't a 0 or a -1, we do this stuff. We push the value and then we say that we pushed it. Oh, because I already had a variable named I. I guess we're going to call this one P for pop. Or V for value or whatever. And it wouldn't take that much time to see if the stack was empty or not. If iStack.isEmpty equals false, then we would pop a value out of it. Else we could say no such data. System.out.println, sorry, stack is empty. All right, this code is getting well beyond what will fit on one page. I'm going to do a little bit of optimization. Since we only have one statement here, we don't need these braces. I'm going to move these braces up to the same line that contain them, just to get more code on the page at the same time. Do that for true. Okay, so I think that's clear. If it's a -1, we want to stop adding anything. If it's a 0, we want to pop one item off as long as the stack is not empty. If it is empty, we're going to print sorry, stack is empty. And if neither one of these was the case, we're going to push our item onto the stack. Each time we loop, we're going to print out the entire stack. When we get into the stack, this isn't actually going to display anything because a for each loop doesn't do anything if it's empty. All right, a series of numbers, 10, 20, 30. So right now we have added 3 items to it. We have a 10, 20, and a 30. Let's pop an item. We popped 30, so now all that's left on our stack is 10 and 20. Let's pop another one. Now all we have is a 10. So a stack is considered last in, first out. The first thing you put on it is the bottom, so it's going to be the last thing you get out. That's different from a queue, where typically you're adding things on to the end, but you're getting things off the beginning. If you had a bunch of people in queue for a movie, you wouldn't want to let the people who are at last go in first. Instead, you would take from the first. So stacks in computer languages, what are they used for? Well, the easiest example, I think, is if you're in a word processor and you type something HELLO, those 5 things are on a stack. And if we want to undo them, we undo the, whoopsie. Okay, fine. There's one thing, there's another, there's a third, but now I'm going to undo one of them. I am undoing. And then when I get tired of undoing, I can start typing. Then I can undo that again. You can see that the last thing I did is the first thing that's undone. So all these changes are made on a stack. Okay, so right now our stack only contains 1 value, I believe. We're going to pop one more thing off it. We just popped a 10, so the stack is empty. If we try to pop one more thing, we get sorry, stack is empty. Now let's add some new things to it. 5, 6, 7. We add 3 values. Let's add 4. 8, 9. And now we're going to quit our stack. And it didn't display the stack because I moved that code up. Let's write some code that will sum all the values on the stack. So after they type -1, we can sum them all. Then we could average them or whatever, but the sum. We're going to do this with pops. We're going to wipe out the stack so that it's empty after we've got them all. So same idea. For every I that's in iStack, let's add that to the sum. And then let's print out the sum. I haven't declared my sum variable, so I'm getting an error. So let's declare a sum. I'm going to make it a double just so that if I do some division, I don't worry about it rounding down. And then I'm going to declare a counter. Which is going to just be set to the length of the stack. And I want to get the size of the stack before we start popping things off, because if we get the size after we popped everything off, it's going to be 0 and we won't be able to calculate the average. So now we can calculate the average. Double average is equal to the sum divided by the count. And if they didn't have any data on it, this is going to blow up. We ought to check for that, but we're going to skip that. Okay, 10, 20, 30, 40, 50. We pushed 5 things on it. Now let's pop 2 of them. 0, 0. We removed the last 2 things. Now let's add 5 more things. 9, 8, 7, 6, 5. Let's pop 2 of those. Now since we've added 10 things and popped 2 of them, then we should have 6 items on the stack. I don't really know how to prove that but I could add 1 more thing to the stack and that would prove it. Okay, we're going to add a 1 to the stack. Now our stack size is 7, so it was 6. Let's pop that last value off. Our 1 is gone. Now let's quit adding things to our stack and it will calculate the sum and the average. That's the sum and that's the average. And that's really all we need to know about stacks in order to do the assignment. The assignment is to ask for input, and if the value is even, then do one thing like add it to the stack, and if the value is something else, then pop and sum all the items on the stack, that kind of thing. Let's go take a look at that. So the assignment over stacks uses all the same technology we've already talked about. We will use the stack class. It will accept whole numbers as input. We'll put it in a while loop, or whatever your favorite kind of loop is. You'll ask the user for a number. If they type in 0, it pops off all the numbers on the list and sums them. Then the stack will be empty. If they type in a -1, it quits. If the number is even, then it pushes that number onto the stack. If the number is odd, it pops the last value on the stack, it multiplies it by what they just entered, and displays that. So if they type in a 2, and then a 4, and then a 6, we'll have 3 things on the stack. But then if they type in an odd number like 9, it pops the last number off the stack, and then prints the multiple of those 2, 6 times 9. And then when they get tired of playing with it, then if they type in a 0, it would add up everything on the stack. Right now there's only 2 numbers on the stack, so it would print out the sum of 6. And then we're really tired, so we type in -1, and it quits the program. All right, I'll upload this as sample code. I'll put it in the same Dropbox as the stack problem itself.
That's So I was trying to find one.